Hello, everyone, and welcome back to Teach Astronomy. My name's Victoria, but you can call me Vicky. And happy Monday, or happy late Monday, or almost Tuesday for some of you. I know some people it's already way late at night, and your Monday's almost over. But hope everyone is having or has had a good day and is excited for some book stream today. So today we are going to be reading chapter 3 or 4 technically. This book's kind of confusing because every time I label it relative to the introduction being just an introduction, but technically it's a chapter. But this is the chapter about Voyager. Either way. So today we're going to be reading about Voyager, and this chapter is actually super long. This is the longest one in the book, and it's about 38 pages, 38 pages. And last week's was 34, and we tried to speed through it, and it still took us 2.5 hours. So I think we're only going to do the first half of this one, just because it's quite long. So this will be part 1 of chapter 3 about Voyager. So it'll still be definitely at least an hour, probably closer to an hour and a half long, that we'll be hanging out here and chatting. So I guess we will just jump right into it. And let me know if you're here. Give me a hey, give me a hi, give me a how you doing in the chat. Let me know how your day's going. All right. Let me know what you think of Voyager. I'm very excited about reading about Voyager. Mainly because I just think Voyager's really cool. Hi Alexandra, how you doing? All right. So, Voyager, Grand Tour of the Solar System. There's a NASA website where you can follow the 2 most distant human artifacts as they sail into the void of space. The real-time odometers for Voyager 1 and Voyager 2 spacecraft flick silently upward. Single kilometers are a blur. Even the tens of kilometers digit changes too fast to follow, while the hundreds of kilometers digit ratchets up by 1 every few seconds. These large and rapidly growing numbers are mesmerizing in the same way as counters of the national debt or the world's population. Numbers this large are difficult to fathom. By late 2015, Voyager 1 was 19.8 billion kilometers, or 12.3 billion miles from Earth. And its near twin Voyager 2 was 16.3 billion kilometers, or 10.1 billion miles from the Earth. Their feeble radio signals take more than a day to reach the Earth as the probes streak through space at approximately 58,000 kilometers per hour, or roughly 36,000 miles per hour. To see why these spacecraft represent such a leap in our voyaging through space, consider a scale model of the solar system, where the Earth is the size of a golf ball. On this scale, the Moon is a grape, where the 2 objects are held apart with outstretched arms. That gap is the farthest humans have ever traveled, and it took $150 billion at 2011 prices to get 24 men there. Mars on this scale is the size of a large marble at the distance of 1,100 feet at its closest approach. As we've seen, it took an arduous effort spanning more than a decade before NASA successfully landed a probe on our nearest neighbor. A very deep breath is needed to explore the outer solar system. In our scale model, Jupiter and Saturn are large beach balls, 1.5 and 3.5 miles away from Earth, respectively. And Uranus and Neptune are soccer balls, 7 and 12 miles from the Earth. This large step up in distance was a great challenge for spacecraft designers and engineers. On this scale, the Voyager 1 and 2 spacecraft are metallic motes of dust, 48 and 37 miles from home, respectively. And actually, before we go on, I want to check and see, because that was the 2015 numbers. I want to see what it is at now. I'm glad you were finally able to tune in for a live stream. I hope you enjoy book stream. We read books and hang out. Hi Parzival, how you doing? Let's see. I'll pull up that Voyager NASA site because it's really cool. Here it is. There we go. So this is the Voyager website that the book was talking about. And I think there's a way to expand Yeah, there we go. So if you go to the mission page, it'll give you more details. But these are the current times and locations for the Voyager missions. So Voyager 1's been going for 43 years. Well, both of them have been going for 43 years. Difference of about a month, and I guess a little less than a month. And these are their distances from the Earth. So currently, Voyager 1 is 14 billion miles away, and Voyager 2 is 11.7. So it's getting close to 12 billion miles away, which is crazy. And then a little bit different if you're looking at the distance from the sun. And then these are their velocities with respect to the sun. They've got their one-way light time. All this really cool information. They also have statistics on what is still operational on each of the... and I don't know what these links are, actually. There's more information on why they turned off some of the instruments, some of the science instruments that are on board. So it's a really cool website to check out if you're into Voyager. And it's obviously constantly updating. So that's pretty cool. But yeah, I just wanted to give you guys current numbers for those. Hello, Lynn, Jersey. How you doing? Good morning. Or I guess in Jersey it's already early afternoon. So good early afternoon. All right. The great 13th century polymath and Dominican friar Albertus Magnus, like many before him, wondered about other worlds. He framed the issue in a way that would be familiar to a modern scientist, saying it was, quote, one of the most noble and exalted questions in the study of nature, end quote. Before the Voyager spacecraft did their grand tour of the outer solar system, the gas giant planets were ciphers, barely resolved by the largest ground-based telescopes. Imagine trying to see details on beach balls and soccer balls that are miles away. Appetites had been whetted by the Pioneer 10 and 11 probes, which flew by Jupiter in 1973 and 1974, with Pioneer 11 going onward to Saturn in 79. But the twin Voyagers promised to send back much sharper pictures. In the 1970s, theory suggested that the gas giants were spheres of hydrogen and helium similar in composition to the Sun. If they had solid cores at all, the surfaces would be at temperatures of tens of thousands of degrees and pressures many millions of times that at the Earth's surface. Their moons were assumed to be inert and uninteresting rocks like Mercury or the Moon. The word world comes from the Old English world, spelled W-O-R-U-L-D, referring to human existence and the affairs of life. Yet the outer solar system seems inhuman and inhospitable for life. Or is it? Just a year before the launch of Voyager, Cornell University astronomers Carl Sagan and Ed Salpeter published a provocative paper in which they argued that free-floating life forms might populate the temperate upper reaches of the gas giants. The authors pushed the concept of life far beyond the bounds of terrestrial biology. Aerial gas bags sounded like a conceit of science fiction, but at the time, no one could prove them wrong. Like explorers venturing into terra incognita, nobody knew what the Voyagers might find. Hello, oh no, it's Anna. Hi, single-coded. It's evening there already. The days. Sounding like it's, you saying it's evening, just, it spooks you sometimes because it's like, oh my god, wait, what time is it? It's only 10. I still have time to get all my stuff done. You guys can't see my to-do list on the board. There's something else on the board. I don't know if you guys can tell what it is. I tried to draw something. All right. Gravity's helping hand. Apollo 13 was crippled. 200,000 miles from Earth, an oxygen tank had exploded. Damage to the command module was so extensive that the crew of three retreated to the lunar module, which they then had to use as a lifeboat to return home. Flight director Gene Kranz aborted the moon landing and considered the options. The simplest would have been to use the command module engines to reverse its direction and head for home. But it was unclear if the engines could be used safely, and Apollo 13 was already in the grip of the moon's gravity. So instead, Kranz authorized the use of the lunar module engines to steer a course that would take the spacecraft behind the moon and get a gravitational assist from the moon that would send it on the correct trajectory for an Earth landing. It was a gutsy call. The world waited tensely as the spacecraft got a helping hand from gravity to bring the astronauts home safely. Traveling in the solar system is a tussle with gravity, every aspect of which affects the amount of fuel required for a mission and so also its cost. The initial problem is leaving Earth's gravity. This is accomplished in 2 steps. First, by a large, expendable chemical rocket that can get the spacecraft into orbit and then is jettisoned. Second, by rockets on board the spacecraft, which give it the extra 40% of velocity needed to escape the Earth's pull. The escape velocity of Earth is 11.2 kilometers per second, or 25,000 miles per hour. Once achieved, the spacecraft is in the sun's grip. Going to Venus or Mercury seems like the easy choice, since the spacecraft can swoon into the sun's gravity, which will pull it inward. But the problem emerges when the destination is reached. How do you slow down enough to carefully study or land on your target? Going to Mars and the outer planets means swimming against the tide of the sun's gravity. The sun is remote, but extremely massive. So having left the Earth, it takes an extra 12.4 kilometers per second to reach Jupiter, and an extra 17.3 kilometers per second to reach Saturn. Compared to what it took to leave the Earth, that's a similar amount of extra energy to get Jupiter. Compared to what it took to leave the Earth, that's a similar amount of energy. Oh gosh, getting tongue-tied already. It's not looking good. Compared to what it took to leave the Earth, that's a similar amount of extra energy to get to Jupiter and twice as much extra energy to reach Saturn. Leaving the solar system entirely requires a velocity of 42.1 kilometers per second, or a whopping 94,000 miles per hour. Where is all this energy going to come from? The answer to both questions lies in gravitational assist. Russian theorists Yuri Kondratyuk and Friedrich Zander pioneered the idea in the early 20th century, and American Michael Minovich added important refinements later. Gravity assist was first used by the Russians to let Luna 3 photograph the far side of the moon in 1959. NASA reprised the maneuver in 1970 to rescue Apollo 13. Here's how it works. Imagine standing beside a railroad track as a train approaches. You throw a tennis ball at the front of the train and it comes back in your direction at a higher speed because the train transfers some energy to the ball. Similarly, if the train was traveling away from you and you threw the ball, it would come back more slowly because the train took away some of the ball's energy. Notice that energy doesn't appear or disappear mysteriously. When the train is coming toward you, hitting it with the ball actually slows it down, but by an incredibly tiny amount because it's so massive. When the train is going away from you, hitting it with the ball speeds it up by a tiny amount. In the case of gravity, there's no physical contact as the force operates through a vacuum. When a spacecraft approaches a slower moving planet from behind, the spacecraft slows down by transferring some energy to the planet. Conversely, when a faster moving planet approaches a spacecraft from behind, the spacecraft speeds up by gaining some energy from the planet. The idea works with moons as well as planets. Pioneer 10 was the first NASA spacecraft to benefit from gravity assist, using an encounter with Jupiter in 1973 to double its speed and send it someday out of the solar system. Pioneer 11 followed suit a year later. Also in 1974, Mariner 10 passed close by Venus on its way to exploring Mercury. More recently, the Messenger probe needed 1 flyby of Earth, 2 flybys of Venus, and 3 flybys of Mercury to lose enough energy to be captured into an orbit of the innermost planet in 2011. For probes heading into the outer solar system, it's worth going out of your way to get a boost from gravity. Galileo and Cassini both took inward detours to Venus to get a kick that helped them explore the gas giants. Energy truly is conserved in this gravitational ballet. When Messenger used Mercury to slow down and go into an orbit, it gave the planet some energy and nudged it a tiny bit farther from the sun. And when Pioneer robbed Jupiter of some of its energy, it pushed the giant planet very slightly closer to the sun. The two Voyagers launched from Cape Canaveral in Florida in the summer of 1977. Their Titan III/Centaur launch vehicle only provided enough energy to get to the distance of Jupiter. Without Jupiter's help, the spacecraft would have remained in elliptical orbits that never got closer to the Sun than Earth, and never got farther from the Sun than Jupiter. But NASA engineers had planned for Jupiter to be coasting by at the right time to give each of the spacecraft a boost. Although Voyager 1 left second, it took a faster and more direct route that got it to Jupiter first, and then Saturn, but at the cost of not visiting the outermost planets. It could have visited Pluto, but this possibility was sacrificed for a close look at Titan. In 1998, Voyager 1 overtook the slower-moving Pioneer 10 to become the most distant human artifact. Voyager 2 took a more circuitous route through the solar system, flying by each of the 4 gas giants and gaining a modest gravity boost from each encounter. The Voyagers were originally conceived to take advantage of a once-in-176-year opportunity, the near-perfect alignment of all 4 gas giants and Pluto. Aerospace engineer Gary Flandreau pushed for NASA to take advantage of the alignment with a planetary grand tour, but the vision was compromised by budget cuts, so the Voyager executed a scaled-back version of this concept. And that's the end of that section. You've been reading books by Graham Hancock. Do I agree that an advanced civilization was right about... Honestly, as far as advanced civilizations go, I mean, like, if you just mean like an ancient civilization, I think there were pretty advanced ancient civilizations, like people built pyramids, and that's pretty advanced to me. I can't build a pyramid, but I don't know anything about Graham Hancock or specifically that situation. I'm sorry. But what I did wanted to show you guys is at the end of that section, there was a little figure. Here it is. So this is the Voyager paths. So Earth is here. Or, well, Earth is on that ring, I suppose. That might be the sun. That might be Earth orbit. But yeah, so you can see that Voyager 1 launched on September 5th. Voyager 2 launched on August 20th, but the reason that Voyager 1 is ahead is because of the orbits that they took. Voyager 2 kind of hung out longer by the planets and didn't get that huge boost until later, so Voyager 1 just kind of took off. And then Voyager 1 visited Jupiter and Saturn before leaving for the outer solar system, whereas Voyager 2, like I said, hit Jupiter, Saturn, Uranus, Neptune, and then headed off into the distance. And neither of them were able to see Pluto, I believe, because, like it said, Voyager 1 wanted to see Titan instead, because Titan is a moon of, oh, Jesus. Is it Saturn? Is Titan a moon of Saturn? Hold on. It's either Saturn or Jupiter. Let's find out. Saturn. Titan's the largest moon of Saturn, and it's one of the popular, along with like Europa and some others, one of the popular places that life is being looked for, or being suggested to look in those locations. But we wouldn't get pictures of Pluto until New Horizons, which happened semi-recently, and it has also... I don't actually know if the New Horizons craft has technically left the solar system. I'm sure. Let's see if they have a... I wonder if they have the same kind of like ongoing mission calculator as they do with the Voyager missions, because it's still going, I think. First mission to the Pluto system and the Kuiper Belt. Yes. I actually don't know. But New Horizons got to Pluto a little while ago, and got some great pictures, and that's why we know that Pluto has a heart. Also, since I'm talking about it, subscribers you guys have a new emote. It's very cute. I made it the other day. It's Pluto's heart. So if you're a subscriber, that's first tier along with the Einstein mask. So you guys can use both of those now. It's very cute. But yeah, New Horizons, I don't believe it's actually exited the solar system. I'm not quite sure. But yeah. Cool stuff. Oh, and I'll give you guys the description of what's underneath. I guess I already did. Yeah, I was gonna read you guys the little text under the picture, but I essentially explained it, so I think we're good. Okay, just going to take a quick. It's so cute, isn't it? I had fun making it. It was fun. It was easy because the heart's it's already there. I just had to trace over it with some red, you know? It's precious. All right. The tireless twins. Here are the basics of these twin long-distance explorers. The Voyagers are nearly identical spacecraft, each weighing about 800 kilograms, the same as a very small car. The heart of each spacecraft is a 10-sided polygon which contains the electronics and which shelters a spherical tank holding the hydrazine fuel. The polygon is fronted by a 10-foot diameter high-gain antenna, which has kept communicating with the home planet even as it receded to a tiny dot billions of miles away. Attached to one side of the polygon is a gold long-playing record. This apparent incongruity will be discussed later. Voyager's 10 scientific instruments are attached to a couple of booms that extend away from the central polygon. The instruments include cameras and spectrometers, and they are devices for measuring magnetic fields, charged particles, cosmic rays, and radio waves. The video camera is based on a design developed by RCA in the 1950s. It seems hopelessly archaic, yet the Voyager Vidicons were very robust and they worked flawlessly. The mission cost $865 million through the Neptune encounter, and has been continuing on a dribble of funds as the spacecraft head beyond the solar system. That works out to 5 cents per mile, cheaper than running a fuel-efficient car like a Toyota Prius. Actual fuel efficiency is even better. Each launch vehicle had about 700 tons of fuel. So far, the Voyagers are getting about 80,000 miles per gallon. Solar power is inadequate in the outer solar system. Too little radiation would reach the spacecraft. Voyager used an onboard power system called a radioisotope thermoelectric generator, or RTG. 3 of these were attached to a boom coming off the spacecraft. RTGs had been used by the Viking and Pioneers previously, and subsequently they've been used by the Galileo, Ulysses, Cassini, and New Horizons spacecraft. Each RTG uses a fist-sized radiation source containing plutonium oxide to generate heat, which is continuously converted into electrical current. Plutonium-238, which is distinct from the plutonium-239 that's used in nuclear weapons, decays with a half-life of 88 years. The Voyagers were getting 470 watts of power at launch, but now they're down to 250 watts. That gentle decline in power is an inevitable consequence of nuclear physics, and as power has diminished, instruments have been switched off. In a few years, the gyroscopes will be shut down, and in the mid-2020s, the Voyagers will go silent. These are remarkable little spacecraft. Even though they are long in the tooth and obsolete by modern standards, they continue to generate scientific discoveries after 35 years. Actually, 43 years. Think of it. They communicate at 160 bits per second, or a lower information rate than spoken speech, and 25,000 times slower than basic broadband internet service. They do their work with less than 3 light bulbs worth of power, and they've barely used half of their 220 pounds of hydrazine fuel after traveling 10 billion miles. On the Earth, 8-track tape decks and LP records have been relegated to yard sales. At the edge of the solar system, they're still cutting edge. Moreover, the Voyagers are not too old to learn new media tricks. They have 400,000 followers on Twitter between them, with Voyager 2 being the more garrulous of the pair. Ed Stone is the father of these middle-aged twins. Stone has had a storied career, serving as director of the Jet Propulsion Lab and chair of the Division of Physics, Mathematics, and Astronomy at Caltech. He's a fellow of the National Academy of Sciences and winner of the President's National Medal of Science and NASA's Distinguished Service Medal. He also has asteroid 5841 named after him. Stone has been principal investigator for 9 NASA missions, but the Voyagers hold a special place in his affections. He started working on the project in 1972. He's nearly in his 80s, and he has no intention of retiring or slowing down. He intends to follow their progress all the way into the depths of interstellar space. In a 2011 interview, he allowed himself some introspection. Quote, "What a journey, what a thrill. We were finding things we never imagined, gaining a clearer understanding of the environment of the Earth was a part of. I can close my eyes and still remember every part of it." That's the end of that section. It's like a cookie, like little hearts. Yeah, it looks like a little cookie. I don't know if I actually have a picture of... Yeah, this book doesn't actually show a picture of the probe, so I'm going to pull that up. Because it's cool. And I want to show you. Open the image. Yes. Okay. So this is what they look like. And like they said, they're essentially twins. So these look, 1 and 2 look about the same. And this is what they meant by, so this is the hexagonal or polygonal, I forget what they call it. But the shape, where the fuel and the electronics box is, and then the probe or the arms here. These arms are different antennae, or here is like some of the science equipment, stuff like that. I'm actually not sure which one is the specific antenna that like sends back to Earth, or if there are multiple. But yeah, that's what it looks like. Yeah, it's like an octa. I don't know how many sides that was. I think they called it a polygon, just to cover all the bases. But yeah, it's very cool. Very cool craft. All right. A family portrait. The Voyagers took a part of the solar system that had been studied briefly and in little detail, and fleshed it out into a family portrait of 4 giant planets, their ring systems and magnetic fields, plus 48 of their moons. The additions and revisions have been enough to cause textbooks on astronomy to be rewritten. Let's see what we learned about major members of the family. First up was Jupiter. This mighty gas giant is 3 times more massive than any other planet, and 320 times more massive than the Earth. The Voyagers reached Jupiter in 1979, with a separation of 4 months. Even after centuries of telescopic observations, there were surprises. The Great Red Spot was revealed to be a huge anticyclone, large enough to swallow the Earth, with eddies and smaller storms around its periphery. It had changed color from orange to dark brown in the 6 years since the Pioneer flybys. As they passed behind the planet, I don't know if you guys can hear, but there's a leaf blower right outside my window. Hope it's not too loud. Okay. I don't know what they're leaf blowing. It's cement outside. All right. As they passed behind the planet, the Voyagers saw lighting illuminating the darkness of the night sky atmosphere. Voyager 1 discovered a very faint ring system around Jupiter made of dust ejected from the inner moons after high-velocity impacts. The rings are far less dramatic than Saturn's, but are equally interesting scientifically. The main ring circles from 122,000 to 129,000 kilometers away from the center of the planet. Voyager 1 discovered 2 substantial new moons of Jupiter, Thebe and Metis. Both are irregular in shape. Thebe is 70 miles in its largest dimension, and Metis is only 35 miles long. Voyager 2 got into the act by discovering Adrasta? We'll go with Adrasty. which is no bigger than a small town, 15 miles across. However, the real excitement came from Io, Jupiter's closest moon and the fourth largest moon in the solar system. This strange-looking rock with its mottled yellow-brown surface looking like a moldy orange is the most geologically active world in the solar system. The Voyager saw 9 erupting volcanoes between them, marking the first time active volcanism had been seen anywhere other than the Earth. Plumes shoot out of the volcanoes at up to 2,000 miles per hour and rise 300 miles above Io's surface. There are more than 400 volcanoes dotting the moon's surface, not all of which are active. Also, before we go too deep into Io, I wanted to show you guys. Oh, you couldn't hear it? That's good. Yeah, I don't know why they leaf blow. It doesn't make a lot of sense to me. And they do it anyway. But in the book, there was a... Oh, not that one. Little figure of comparing Jupiter to the size of Earth. So, yeah. Also, it says the biggest atmospheric phenomena on Jupiter, like the Great Red Spot picture here, rival the Earth in size and persist for centuries. And Voyager gave us new and unprecedented detail on the atmospheric properties of all 4 gas giants and indirect evidence that they possess rocky cores. I'm sure we will get to that part. A little bit of a spoiler. But yeah, so that's a little size comparison between Jupiter and the Earth. It's quite large. What Parzival send me? What is this? What is this? Oh yeah, there's the oh, that's fun. Parzival sent a link to another page from a different website, NASA's like solar system exploration site, where you can it's like you can kind of play around with, I don't even know what you would call this. It's not a simulation, but it's I'll show you. It's this little thing, so you can make it big. There we go. You can see where Voyager is in the sky. I think we've like looked at one of these before, but you can look at different spacecraft like this as well, or go to different places, I'm sure, and just see how things are going. So that's cool. Yeah. So if you guys want to check that out, yeah, it's a live tracker, yeah. So if you guys want to check that out, it's a pretty cool thing to play around with. Yeah, it's moving in reality. It looks stationary here just because I think like the software is just tracking with the craft. So it looks like it's not moving, but it is slowly moving away from the solar system still. Okay, so back to Io. Why is Io so lively? Normally, moons are geologically dead because there's not enough radioactive heating from their interior rocks to drive tectonic activity. But Io is in a gravitational tug-of-war with nearby Jupiter and the other 3 Galilean moons, Ganymede, Callisto, and Europa. This incessant pulling and pushing heats up the interior of the moon, like a racquetball heats up when it's flexed repeatedly. Io is distorted by the stretching force of Jupiter's gravity, and this departure from a sphere is called a tidal bulge. It bulges by up to 300 feet, which is enormous compared to the roughly 1 foot stretching of the Earth's solid mass by the moon. Sulfur and oxygen atoms ejected by the volcanoes create a torus of plasma around Jupiter. And these ionized atoms have been detected millions of miles away, right to the edge of Jupiter's magnetosphere. Lava flows episodically paint the surface red, orange, and yellow, and fizz off enough material to coat the entire surface with an inch of sulfur every year. Galileo's other children of Jupiter turned out to have distinct personalities as well. Ganymede is the largest moon in the solar system, even larger than Mercury and more than twice as big as Pluto, which has seemed poor and misbegotten since astronomers demoted it to the status of a dwarf planet in 2006. Ganymede has terrain that's partially cratered and partially grooved, which is thought to indicate tectonic processes. Rocks mixed with ice comprise the top layer. Well, thank you for that follow, Sarah. Sarmas 5? Welcome to the Teach Astronomy family. Where was I? Oh my gosh, I lost my place. There it is. I think I was here. Ganymede has terrain that's partially cratered and partially grooved, which is thought to indicate tectonic processes. Rocks mixed with ice comprise the top layer. More recent observations point to a liquid ocean under the icy crust. The Voyager saw huge impact craters on Callisto, with a couple indicating impacts almost large enough to blast the moon into fragments. However, the craters were strangely smooth, with almost no topographic relief, indicating that water ice at one point had flowed over them and filled them in. Europa attracted keen attention from the mission scientists when the first images came back. Low-resolution pictures from Voyager 1 showed linear features crisscrossing the surface. Higher resolution pictures from Voyager 2 increased the puzzle because the features were so flat they couldn't have been created by the familiar terrestrial process of slabs of crust sliding and colliding with each other. The only plausible explanation was that they were ice flows. Other observations pointed to a liquid ocean tens of kilometers deep under the few kilometers of ice. Europa vaulted into its current position as one of the most compelling targets for a future lander. Saw the chat was blowing up. Oh, you're interested in anyone's thoughts on SpaceX Starlink affecting astronomy? I could talk about that in a second. I could definitely tell you how to find us on Discord. Let me get to the end of this little section here, and I will drop that link. You guys can feel free to keep talking about SpaceX, though. The Voyager flybys of Saturn took place in 1980 and 1981. They got 4 times closer to Saturn's cloud tops than they did to Jupiter's upper atmosphere. Saturn's magnificent rings were the source of many puzzles and a few surprises. Viewed up close, the rings had incredibly detailed structure. Not only were there concentric rings and gaps ranging from large and fuzzy to razor sharp, but the cameras revealed radial spokes, kinks, and delicate braids. Time-lapse photography proved that some of these features came and went. The rings were made of mixed icy and rocky particles, ranging from microscopic to house-sized, shepherded by Saturn's many small and irregularly shaped moons. The rings of Saturn and other gas giants are the result of an amazingly subtle gravitational dance. With no choreographer other than Newton's law of gravity, a disk of rocky and dusty material can naturally develop. A disk of rocky and dusty material can naturally develop very complex structure. A resonance occurs for any pair of orbits where the periods are related by 2 small integers. In that case, the 2 objects have a boosted interaction that can cause them to rearrange their position, cause one to be ejected from the system, or cause either one to clear out small particles in a ring at a particular radius. Some resonances are stable, such as the orbits of Jupiter's moons, Ganymede, Europa, and Io, which have orbital periods related by the ratio 1 to 2 to 4. Think of a child on a swing. You can sustain or increase their motion not only by pushing them once per cycle of their motion, but also every second cycle, or every third cycle, and so on. Although the principles of orbital resonance are understood, not all the subtle features in Saturn's rings have yet been explained. Voyager also earmarked Saturn's large moon Titan as a place to return to. Titan has a thick atmosphere of nitrogen and was inferred to have bodies of liquid ethane and methane on its surface. As we'll see in the next chapter, Cassini did give Titan the attention it deserved 20 years later. Very little was known about dark and shadowy family members Uranus and Neptune before Voyager. The highlights of Voyager 2's solo flybys of the 2 outermost planets included the discovery that the magnetic fields are tilted far from their rotation axes. The new data trebled the number of moons of Uranus from 5 to 15. 27 are now known, most named after characters in the plays of William Shakespeare, and a few named after characters in Alexander Pope's poem, The Rape of the Lock. And it doubled the number of moons of Neptune from 3 to 7, and 13 are now known, named after Greek and Roman water gods. Miranda, the innermost of Uranus's 5 large moons, is a bizarre object. Even though it's only 300 miles in diameter, it has huge canyons and terraces 10 miles high and mixed young and old surfaces. Voyager scientists thought it might have been the pieces of a smashed moon that came back together. But now it's thought that Miranda's topography arose from tidal heating at a time when it was in a much more eccentric orbit than it is now. Neptune rounds out the family portrait. This frigid and gloomy planet has howling winds of 1,200 miles per hour and a great dark spot similar in size to Jupiter's great red spot. Its large moon, Triton, might have been kept molten for 1 billion years after its capture by Neptune. Geysers on its surface spew soot and nitrogen gas into its sparse atmosphere. Triton is the coldest place in the solar system, negative 391 degrees Fahrenheit, a temperature at which the air we breathe would freeze solid. And that's the end of that section. It would be very unfortunate if the air we breathed froze solid. That would be quite a problem. But yeah, while we take a quick little break, I'm going to grab that that link to our Discord. So if you, sorry, I went to our YouTube page to grab the link, and a video of Chris started talking to me, and it spooked me. But for those of you who don't know, we have a little Discord. I say little. It started little, but it's a Discord server where we now have something like oh, thank you so much for that anonymous cheer. Thank you so much. I love the little ghost. Thank you. But we have a Discord server. That's the link there, and we have, I think, 1,400 members now. It's a lot of people. So you guys can join that. Everyone can join, and then there's also a little special channel on there, a chat channel for subscribers only. So if you are a subscriber, that actually reminds me, if you are a subscriber and your username on Discord is different than your username here on Twitch, just send me a message. You can find me. I'm an admin, so it should be pretty easy to find me. You can't get on there. Is that not the right one? Let me see. Is it not working? It worked for me. Oh, you can't get on the special server or on the whole thing? On Astropedia or on the subscriber one? You can get on Discord, but not that. Just let me know what your you can't get on Astropedia. That's weird. You know what, Masanova? Yeah, we are Astropedia. Yes. It's called Astropedia because that was actually the original name of our course, I believe. I don't actually remember why it's called Astropedia. Even our YouTube channel, our TeachAstronomy YouTube channel is technically called Astropedia in the URL, because that was our original channel name, which is weird. But if that doesn't work, I can try to troubleshoot with you towards the end of the stream, Charlie, if you want, because I want to make sure you can get on that Discord, and also I can give you access to the subscriber one. But yeah, so if you are a subscriber here and you notice that you cannot get access to the Twitch subs channel, if you don't see that, and you are a subscriber, just send me a message. You'll see who I am on Discord, and tell me, like, hi, I'm so and so from Twitch, but I go by this on Discord, and I will confirm that you're a subscriber and put you in there, because I know some people just don't use it, but some people also just have different names. And also with the Starlink, we talked about it a little while ago. We haven't talked about it lately, but we've been talking a lot about Perseverance and stuff, but I'm sure it'll come up again soon because it's still going on. Starlink is a huge problem, and I'm not a big fan of it, mainly because I would be more of a fan of it if it actually was, if it actually was like doing the thing that is like the good thing that it's supposedly doing, which is bringing like high-speed internet to places where that is not available for affordable prices. It is not. It's like $100 or something a month. It's ridiculous. And like that's not providing, I don't know if they have future plans to provide like, you know, free or super low cost internet to places that, you know, places and families and people that like are in need of that, because it's a, you know, the internet is a serious, it's a utility, you know, it's a resource that everyone kind of needs now. And, you know, if it was doing that and actually providing that for like a low cost, I would kind of be more on board. But right now it's kind of just another internet service that's really expensive, for rich people, that is also going to kind of screw over, astronomers and amateur. Yeah. Like Oh No, It's Anna said, ruins amateur astrophotography, professional astrophotography, academic work, stuff like that. There's just like, it just causes so many problems. It's just it's a bit of an issue. Oh, I like Bossa Nova. You're on there. Okay. And your name is Tasmanian. All right. I will write that down. And I will add you to the subserver after this stream. But yeah. You guys are talking about lungs freezing. Your lungs can't clear and it'll burst due to high pressure. Yeah, it wouldn't go well. It happened really fast probably. And also we'd suffocate because, like, you know, space. So Starlink equals more money. Oh yeah, definitely. So many of my students here worship Elon and jump on me when I was skeptical about it. No, we kind of also touched on that a little bit too, but like, yeah, a lot of people are kind of it feels almost like I think people used to do this with like Steve Jobs when he was around, but it's like that, like worshiping, you know, Elon Musk or, you know, Jeff Bezos or something, just like people who, you know, have built huge industries and stuff. And like, I don't really like that. I don't know. You know, there are better people to look up to. But yeah, some people are like very much on the Elon Musk train and everything he does is great. I am not one of those people. Michael is not one of those people. And we just call it as we see it. Oh yeah, that's the problematic thing, is like he can do no wrong. You know, everyone can do wrong, and we should call him out for it. It's a bit of a problem. Starlink is a bit of a problem. Yeah, the way he thinks, it's not that much worth for now. That's fair. I mean, yeah, it is inspirational. You know, he made a company and stuff, but yeah, I think it's problematic to think that he's just like, everything he does is great, because everything, I mean, a lot of big industry things, there's always a good side and bad side. So yeah, that's all. That's my opinion. Also, no one's I guess I drew it bad, but no one's been able to guess what's on the whiteboard yet, or no one has bothered. So let me know if you know what's on the whiteboard behind me, and I'll keep going. Okay. Beyond the solar system. Mission creep is NASA jargon for the situation when new goals or capabilities, and usually extra associated costs, are added to a mission as it is being developed. The phrase has negative connotations, but the Voyager spacecraft wear it as a badge of honor. Their original 2-planet mission was designed to last 5 years. With all the objectives for Jupiter and Saturn achieved, flybys of the 2 outermost planets, Uranus and Neptune, proved irresistible to mission planners. The 5-year mission extended to 12. As the spacecraft moved into uncharted territory, the time it took for a round-trip signal to be sent from JPL stretched to more than a day, So engineers figured out how to program the Voyagers for remote control, allowing them to be more autonomous. Now the mission has been running long enough that the Voyagers may outlive many of their designers. As the Voyagers recede from Earth, the modest power sent back with their high-gain antennas dilutes through an ever larger volume of space. Currently, the Deep Space Tracking Network detects a minuscule 10 to the negative 16 watts, equivalent to a billionth of a light bulb, from each spacecraft. Okay, I guess you guys did get it. It is the golden record. Yeah, the Voyager message. Yeah, you guys got it all right. It's very rough drawing. I'm obviously going to give you guys an actual picture of one of those when it comes up, but I think that's actually going to be in the second part of this chapter, which we're going to do next week. If you guys weren't here in the very beginning, we're only going to do the first half of this chapter because it is super long. It's the longest in the book, and we definitely wouldn't get it in even 2.5 hours. We wouldn't get through it. So we're doing half today. Anyway, what lies beyond the solar system? Uranus is at 30 AU, or 30 times the Earth-Sun distance. From 30 to 50 AU lies a vast ring of debris similar to the asteroid belt. Called the Kuiper Belt, it contains about 100,000 rocks larger than 30 miles across, including some dwarf planets. Where the solar system ends and interstellar space begins is a matter of argument. The sun sends high-energy charged particles out from its upper atmosphere in all directions. This solar wind streaks past us at a speed of 1,000,000 miles per hour and creates an evacuated region or bubble called the heliosphere. The heliosphere extends past all the planets and ends when the solar wind runs into the rarefied gas of hydrogen and helium that permeates the region between stars in the Milky Way. A shock wave is created as the rapidly moving wind slows to subsonic speeds. The location of this boundary layer is one of the big unanswered questions in astrophysics. The Voyagers have several ways to diagnose the invisible processes that take place in the near vacuum of the outer solar system. They can study the strength and orientation of the magnetic field of the sun, the composition, direction, and energies of solar wind particles, and the strength of the radio emission from beyond the heliosphere. At the boundary is the place where the solar wind slows suddenly from a speed of 1,000,000 miles per hour and becomes a lot denser and hotter. In December 2004, Voyager 1 crossed this shock. A few years later, Voyager 2 followed its twin into the unknown. Recent results have been surprising. The edge of the solar system isn't smooth, but is filled with chaotic magnetic bubbles 100 million miles wide. These bubbles are formed when the sun's distant magnetic field lines reorganize and form separate structures. Until this observation, it had been expected that the space far beyond the sun would be smooth and featureless. In December 2010, Voyager 1 saw the outward speed of the solar wind particles slow to zero. Stagnation of the solar wind was unexpected and may mean that the spacecraft are on the verge of entering a new realm, the vast space between the stars. Voyager is as ambitious as any project humans have undertaken. To date, the 13,000 work years devoted to these spacecraft are half as much as all the labor summoned by King Cheops of Egypt to build the Great Pyramid at Giza, with its slanted passageway so that the dead pharaoh's soul could reside with the stars. Now, 4,500 years later, we have the means to go there directly as our robotic emissaries glide towards other worlds. That's the end of that section. Oops. What are you guys talking about? Did I include the golden record in my vinyl document? Oh, I should have! Oh, that would have been so clever! Oh my god, I didn't even... That would have been good. Oh, man. Although, when I made that documentary, I hadn't actually started working with Chris and Matthew, so I don't know if I probably kind of knew about the golden record somewhere back in my brain, but I hadn't really started the astronomy. I haven't hopped on the astronomy train fully. We hadn't left the station completely, But Uranus is not that good. Good of a name. It's Uranus is actually a god. Because all the planets are named after Roman gods. And Uranus is kind of one of the only ones that actually isn't like paired to a very yeah, I guess grandfather of Zeus, is that right? Yeah, Caelus. Caelus in Greek, or no, Caelus in Rome. Oh, so Uranus is, oh, I got it wrong. Uranus is actually Caelus's Greek, so it's the Greek god version. Caelus is Roman, which is interesting. Why would they pick Uranus if they could have done Caelus? That sounds so much nicer. Anyway, but most of the other ones are Roman. So Mars is Ares, Neptune is Poseidon, Venus is Aphrodite. I used to know all of these. Yeah, Venus is Aphrodite. Mercury is Hades? No. This is such a tangent. Oh, Hermes is Mercury. I have always been a huge fan of Greek and Roman mythology since like middle school, because I had a middle school teacher who was like, we're gonna read a bunch of Greek and Roman mythology, and it was a great time. So it's fun to, you know, see them in pop culture lately with some video games, and also in astronomy. Anyway, make a reissued director's cut of the documentary. There you go. Yours are Indian names. Oh, that's cool. Yeah, I never thought about. Tell me. I know we have an international audience. How are your guys' planet names translated? I'm curious. Are they like, because as Parzival said, in India, they're pretty directly just like other like Indian gods, or I guess Hindu gods. Would that be Hindu? I don't want to get that wrong. But Hindu. Okay, cool. But I would love to hear if other people are in other countries, like what how the translation works. Let me know. Okay. Strange New Worlds. Chesley Bonestell's lifelike paintings of Saturn as seen from the surface of Titan and other moons, published in 1944 in Life magazine, sparked the public imagination regarding the kind of geographies we would someday find in the outer solar system. In characterizing the large gas planets and their moons, Voyager confirmed what astronomers had long suspected. The Earth, to some degree, serves as an analog for meteorological and geological processes on other worlds. Serge Brunier explains, quote, fogs, clouds, glaciation, the cycle of the seasons, aerial erosion, and volcanism are universal phenomena, end quote. But the geological processes occurring on worlds billions of miles from the sun both surprised and mesmerized scientists and space enthusiasts across the globe. Close-up views of Jupiter's moons indicated internal heating as they flex in the tides of their host planet's gravity. A probable ocean of water captured under the fractured and icy surface of Europa, and tightened seas of liquid methane, both suggested strange and captivating geographies. Planet encounters garnered global attention and were keenly covered by the press. When Voyager 1 arrived at Saturn in November of 1980, Henry Dethloff and Ronald Shorn report that approximately 100 million people tuned in to live television broadcasts from NASA's Jet Propulsion Laboratory, while roughly 500 reporters from across the globe provided news coverage, quote, unprecedented in the history of unmanned space exploration, end quote. It's no wonder public interest in the mission was so intense. Voyager literally beamed into our living rooms footage of worlds being charted for the first time. Of Voyager 1's encounter with the second largest planet in our solar system, former JPL director Bruce Murray writes, quote, Both Time and Newsweek ran Saturn cover stories. Live programming flowed daily from Pasadena to a network of viewers in countries ranging from Canada to Finland and especially Japan. Colorful images of Saturn surrounded by its magnificent rings rapidly became pop art cultural symbols. End quote. Saturn's weather turned out to be wilder than Jupiter's. A layer 12,000 miles, 1,200, sorry, not 12,000. A layer 1,200 miles thick has winds of over 1,000 miles per hour. Murray recalls that President Jimmy Carter, curious about wind speeds and whether auroras had been detected on Saturn, phoned to say, quote, "The Saturn pictures are fantastic. I watched 2 hours yesterday as well. Didn't expect to have so much time available." End quote. In the summer of 1989, when Voyager 2 arrived at Neptune and its moon Titan, black and white still images were broadcast live as they streamed from the spacecraft, and NASA, PBS, and CNN arranged for live reports at regular intervals through the encounter. Voyager's televised encounters allowed scientists and general audiences the opportunity to ramble, quote, "through a cosmic Louvre," writes Murray. Quote, "For the millions viewing PBS's Jupiter Watch telecasts, ABC's Nightline programs, or Carl Sagan's Cosmos series, or watching the images appearing on screens in Japan, England, Mexico, and South America, Voyager revealed a treasure trove of abstract art." End quote. Carl Sagan was a member of Voyager's imaging science team, and he incorporated into his PBS TV program Cosmos animations of planetary flybys and computer-generated graphics produced at JPL by the Voyager team. Through the PBS series, his book of the same title, and late-night talks with Johnny Carson, Sagan worked to capture and generate widespread public interest in planetary science and the Voyager mission. A celebrated senior astronomer at Cornell University, Sagan dedicated his life to popularizing the latest findings in astronomy and planetary science, at a time when most astronomers were unwilling to risk their scholarly reputations to do so. He fed a fascinated public exactly what they hoped for and wanted. Having researched the atmosphere of Venus as an example of runaway greenhouse effects, Sagan championed NASA's projects and delighted in articulating descriptive imagery, astronomical and planetary phenomena. He delighted in articulating in descriptive imagery, astronomical and planetary phenomena. It was Sagan who suggested that Voyager, once beyond the orbit of Neptune and receding from the ecliptic plane, should capture a photograph of Earth as it really appears in the scale of the solar system, a seemingly unimpressive pale blue dot, as he evocatively named it. That's the end of that section. Sorry, I was just reading through your guys' chat. I just realized I was just staring off into space for a minute. I was just reading the chat because I was so interested in all the names. That's really cool. I wonder if the Hindu gods match up as far as like what they're like the patron gods of to the Roman and Greek ones. Because the Roman and Greek are essentially exactly the same. But that sounds cool. Gaia is a great name. Yeah. Gaia is great. These are really cool. Surya. I'm not going to try to pronounce all of them because I know I'm going to butcher them, but they sound really pretty. That's really cool. Thank you for sharing that. All right. And I think this is going to be the last section of the day, but we've got a fun picture, so we can check that out as well. Okay. I pronounced it correctly. I can't do all of them. No, I'm gonna do it bad. Maybe I'll listen to pronunciations of them before next time, and then I'll try to say them all next time we hang out. Okay. The pale blue dot. Of the stunning images Voyager sent back, perhaps none have more profoundly shaped our understanding of humankind's place in space than Voyager 1's photo of Earth from the icy reaches of the outer solar system. The pale blue dot image represents one of the most significant of the mission and of our time. In February 1990, while 3.7 billion miles from Earth, Voyager 1 snapped 60 photographs looking towards the sun, and over the next 3 months transmitted the images to Earth. Among the last 6 frames of the photoshoot, only one included humankind's most distant view of Earth. When Sagan suggested that Voyager's imaging team attempt the photographs, NASA administrators apparently were reluctant to authorize it, as programming the commands to take additional images was labor-intensive and it was not clear whether the data would be scientifically useful. Candace Hansen, who helped design Voyager's imaging observations, and several others, joined Sagan in arguing for the photographs. Hansen recalls how intently the imaging science team wanted to obtain what was later called the family portrait. Quote, "We were really after the picture of the Earth, so we had to look for the point in the Earth's orbit which would have it as far away as possible from the sun. It turned out that we could also get Neptune, Uranus, Saturn, Jupiter, and Venus." Hansen, like Sagan, realized that an image of Earth viewed from billions of miles away would intrinsically, quote, "strike a chord that might affect people's view of the world," end quote. They couldn't have been more prescient. By sheer chance, the Earth appears in a photo as though caught in a band of a rainbow. This artifact in the image is caused by sunlight reflecting off the spacecraft. Sagan noted that it only accentuated how diminutive our world is in the empty wastes of outer space. Jury Vanderwood, public information officer for the mission, explained the difficulties in actually acquiring Voyager's final 6 photographs, including the singular image of Earth that so powerfully and visually categorized our minute place in space. And before I read the long quote, I'm going to show you guys the photo they're talking about. If it will let me. What's going on? There it goes. Okay. I'm going to pull up this photo for you guys. There it is. And that is Earth. Right there. Okay. Quote, "They were stored on board Voyager on the tape recorder for the simple reason that the Deep Space Network, those big antennas in Australia, Madrid, and Goldstone, California, were too busy with Magellan and Galileo to listen to poor old Voyager. At the end of March, we played that sequence of photographs back, and the last series of photographs, 5 or 6, were being received by the Madrid antenna when it rained. That blocked out the data, so in April we had to give it another shot. This time the antenna in use was the one at Goldstone, which turned out to have a hardware problem. As a result, we still did not get those 6 photographs, so we had to do it again in May, when we finally got them." Win Wackhorst writes, quote, "To stand on the moons of Saturn and see the Earth in perspective is to act out the unique identity of our species," end quote. Wackhorst quite accurately points out that viewing Earth from the outer planets had radically altered our collective human consciousness. The Apollo missions afforded us the first opportunity to see the Earth from 240 million miles away. Apollo 8's photo of the gibbous Earth emerging from the limb of our desiccated and cratered moon, Earthrise, along with Apollo 17's whole Earth photo, are among the defining images of the manned lunar program in the 20th century. Apollo 8 astronaut James Lovell, commenting on the view of Earth as the astronauts orbited the moon in December 1968, noted, quote, "The Earth from here is a grand oasis in the big vastness of space." Voyager, conversely, had captured a chance glimpse of the dot of Earth forging into the empty abyss on its course around the sun. In 4.5 billion years, our solar system has never traversed the same wastes of space, nor will it ever. It is a staggering reorientation made visceral through the photo of the pale blue dot. With that single image, Voyager brought into focus the fractional blue world on which our lives, our narratives, and our art have mattered. And that's the end of that section. Beautiful. I love this picture. It's wild. It is like like 2 pixels. It's crazy. It's so small. There it is. You can cover it with just the tip of the mouse. It's gone. Wild. All right, and I think we're going to stop there for today. We can chit chat a few more minutes. The homegirl read. I can't try to read them. I'm gonna butcher it one day. But yeah, it's cool to learn new names and new stuff. Can anyone read Cyrillic? Actually, my partner took Russian in college and can still read some Cyrillic. It's been a couple of years, but he can read some Cyrillic. I definitely cannot pronounce those, but maybe he can help me out, and I'll try him next time. It's Russian, I think. Yeah, they've got a different alphabet. I've always had a lot of respect for people who can speak and write like I guess write, because speaking is different, but like write and understand and read languages that are based in different alphabets. I'm just trying to learn Spanish. But that's super impressive. Single coded sent something. Oh, Terra. Oh, the goddess of the earth. Amazing. Yeah, so I think that's where the suffix terra comes from. So like terraform or terrestrial or stuff like that, referring to earth, which is cool. Terra is the goddess of the earth in Greek mythology, or no, Roman. Excuse me, Roman. Yes. 5 languages. That's wild. I know a little bit of Spanish and I know English. That's really it. And I gotta work on that. But no better time than the present, right? Maybe I'll start doing that Duolingo. If you guys have learned other languages recently, because I know it's different if you grew up and were raised multilingual or like in school and stuff. But if you've done it post school, what'd you use? Because Duolingo is like okay, but I feel like there are definitely better ways to do it. I know a lot of people just like watch television in other languages. Python definitely counts. Any coding language, I count that definitely, because I can't understand any of that. 2 are mother tongue, 1 is English, and other are foreign language, French, and special Sanskrit. That's really cool. You're trying to understand German next. Oh wow. My friend speaks German. My friend from college, she did a whole like minor in German, and she speaks it pretty fluently because I think her family's part German. But yeah. Cool stuff. You just started Python. Yeah. I heard about that. Very exciting. I tried to make a website yesterday and I had to call my friend who codes because I can't remember a single thing about coding and just even like HTML, which is crazy. But he helped me put the website together, so it was fine. It exists. It's not for this. It's for my podcast. But I think that's pretty much it. I think we'll wrap it up here. Sorry about all the lights. Just going through tabs. But I think we're going to wrap it up here for today. And next week we will do the second half of this chapter because it is a doozy of a chapter. And we will read more about Voyager and stuff about the record I saw in here. And that's a totally different mission. What am I looking at? But it'll be about the record and different other things about the outer solar system and past the solar system that Voyager has discovered. All right. Well, I guess I will see you guys next time. Also, quick reminders. Tomorrow we have Professor Impey's regular Q&A stream on YouTube at, what time? Let me check for you guys. Tomorrow it is not scheduled yet. It should be scheduled. Let me check my messages actually, because I want to give you guys the right date or the time for that. Matthew sent it to me recently. Sorry, guys. 1 second. Besides streams tomorrow, we're going to have our regular Wednesday news stream and Friday amateur astronomy stream, as always. And we're also having our bonus stream tomorrow. That'll be really fun. So anyone who is a subscriber, be sure to be there. And if you want to subscribe, do it now or do it tomorrow, because only subscribers will be able to chat there. It'll be immediately after I could just check when my stream is, because it's the other one is right before that. I'm smart. Let me do that. Let's see my channel. And the schedule. Give me the schedule. Where's the schedule? Oh, goodness. Goodness me. There it is. Okay. Sorry, guys. So the bonus stream tomorrow, the subscriber chat is going to be right here on this channel tomorrow, at 10 a.m. my time. So same time we started today. Which will be immediately after Professor Impey's other stream, which is going to be on YouTube. So you can watch the first one on YouTube, then come right over here. We're going to do subscribers only. So if you are a subscriber, be sure to be there. If you can't be there, message me on, there's in the Discord. You can message the Twitch subscriber channel and send me any questions you might have for Professor Impey. We're going to focus more on things that he doesn't normally talk about, stuff about like his career and his cool life experiences and stuff like that, because he's a really cool guy, and it's cool to hear about his stuff like that. So yeah, I think that's everything we're doing this week. The meme of a black guy thinking and point. Yeah. I'm a meme. Oh, thank you for that. Yeah, and there's Parzival put the link to the YouTube channel if you guys are unfamiliar with that as well. What's my podcast? It's called Cryptid Cape. If you're interested, it's right there. You can find us at cryptidcape.net or on any podcast platform that you choose to listen on. It's a story about a young woman who's looking for a new start and finds herself living in a town full of cryptids. It's great. It's fun. Do we have merch? We do not. I don't know if you're talking about Cryptid Cape or this. We don't have merch for Teach Astronomy. I could make stickers, though. I don't know if people would be into that. Some cute Teach Astronomy stickers. I'll think about it. All right. And I think that's about it. So I will see you guys tomorrow, I guess, because I think I'll be on camera. So bye.